Moving on to Chapter 8. In question 10, we're given parts of a triangle. We want to solve for the missing parts. Since these are not necessarily right triangles, we want to use the law of cosines or the law of sines. Recall the law of sines is A over sine A equals B over sine of B equals C over sine of C, where the lowercase letters are sides and the uppercase letter are the angles opposite those sides. The law of cosines tells us that a squared equals b squared plus c squared minus 2bc cosine A, or b squared equals a squared plus c squared minus 2ac cosine B, or c squared equals a squared plus b squared minus 2ab cosine C. Knowing those equations, we can solve. In this first one, I'm just going to draw a generic triangle. I know it's not going to be to scale. Here I'm given that side A is 3, side B is 4, and side C is 2. I want to solve for angle A. To do this, I'm going to have to use the law of cosines. Since I'm solving for angle A, I'm going to use the equation that has angle A in it. So I get that a squared equals b squared plus c squared minus 2bc cosine A. Please make sure that you group this whole bit together at the very end. A lot of times students will mess up the signs on that. I get 3 squared equals 4 squared plus 2 squared minus 2 times 4 times 2 cosine A. This gives me 9 equals 16 plus 4 minus 16 cosine A. 16 cosine A will equal 20 minus 9, so that's 11. I get cosine A equals 11/16, and to solve for A, I need to take cosine inverse of 11/16. You can plug this into your calculator, but please make sure you're in degree mode for this. We're switching from radians from above to degrees now, and this gives me 46.567 degrees. So the measure of angle A is 46.567.